Right.
Brilliant.
There you go.
So
the recording's kicked off.
Can everyone hear me okay? Yep. So basically, I'm just going to talk you through quite a bit of an informal presentation from a few sort of lessons that I learned from this conference. It's only in June, but it seems like months ago now because it's been a busy time since I've got back. So I'll try and remember and dig out what we learned. So it wasn't a huge conference. This one, it was probably about 100 participants. But that was quite good because it meant that you could have some good conversations on the fringes with a lot of people over the 4 days. So I'll just run through. There's links on here to IEEE where all the papers are. I'm not sure whether you guys have access to that. So I'll actually update that with the one without our proxy in there. So system of systems, I'll just run through one slide just to talk about what it is. But it's basic. There's a number of definitions, and if there's a reference in here that refers to the paper, the first paper I'll cover off. But it's basically a collection of systems where people aren't fully under control. So if you've got operational independence or managerial independence, immersion, evolution, and geographical distribution is one of the definitions. Another definitions around bringing together a set of systems. So often this can be, like an airline industry, in an airline, one system that can be tightly controlled by one sort of structure can be, say, Air New Zealand, but the collaboration of security and airport owners and many different airlines and ground staff and fuel staff and power, air traffic control, etc., becomes a complex, more complex system, all with their own drivers and own independent management, but trying to achieve the same goal of transport. So that would be a good example of a system of systems. So it's quite, the definition's been around for quite a while, but its operation and its maturity compared to some other areas of systems engineering is probably quite low. But when we look at New Zealand and some of our sort of challenges around sustainability or how we work towards UN sustainability goals, I think it's pretty good to try and get some of these concepts just not in outside of our traditional sort of area. Okay, so any questions on that? Just feel free to interject as I go along. I'm happy for people to ask questions. So again, I just put one slide in just for background reference for people with the paper at the bottom there, but that's just a definition of how you can differentiate to say, am I a system of systems or a system? Don't need to worry too much about the detail. To be honest, I think that's the key thing is figuring out how to approach these. And it's almost accepting that you can't fully control them and you can't fully control who joins or who leaves the system of systems. You just need to try and set your systems up so they're adaptable and can evolve and have some good standards, for example. So the paper that I covered off was this one around setting this up for horticulture. So I've covered it before, but the main issue in a lot of industries is there's you get a lot of funding to do and adopt technology well. In a lot of industries like horticulture, you don't often get that money, or it's harder to support things because the utilization might be short. You're only doing a function for 2 or 3 months of the year, or it's quite remote and hard to support things. So New Zealand's really struggling in the primary industries. So it was all about how do we leverage sort of line replaceable units, sharing that human capability. And some of the building blocks in like a jigsaw pattern within the system, so people can build things from a robotic point of view and a cloud digital twin side of things without everybody having to build from scratch. Because in horticulture, no one can afford to do any of this stuff on their own because it's just too expensive. So a number of problems facing horticulture. Labor shortages are often in the news, environmental impact and the cost of growing fruit, just because labor's hard to get. And generally the horrible jobs, so the people don't want to do them, and they're struggling to attract people from overseas to do them. So we were looking at Zespri, going from the on orchard through to the wharf. And the reasons we need this is low utilization of the equipment. So you can get expensive robotics in a factory that's running 24 hours a day or 3 shifts a day, most days of the year. But in horticulture, it might be quite small. You're struggling with small businesses who can't afford to carry that speciality in robotics or sensing or image recognition or any other the buzzwords. And it's in remote areas, so it's hard enough supporting high-tech things in the centers. When it comes to that human capability and spares supply chain, it's a bit of a nightmare. And then a lot of the other side of things, people focus on interoperability, but if you can't afford to build those things to interoperable to operate with each other, when everyone's trying to do everything on their own, then basically, I think New Zealand incorporated can be stronger if we start to reuse some of these things and some of that capability rather than us all trying to build it from scratch, because we're not as big as other countries or deeper pockets or as wide a skill set of people. So the more we can reuse in a common sense perspective and share where we're not competitively competing against each other, the better. So another analogy I've used before is around the airline industry. They're fiercely competitive, but they share resources at the airport. They share people for loading bags to aeroplanes. They share check-in desks. They share facilities. Even though they're highly competitive, doesn't mean you can logically set up a good system that you can share and make sense. I'll just skip through this one. So this is quite a messy slide, but basically we've got a number of sustainability things in the top left, a number of financial things in the top right, a number of challenges around adopting technology, around sort of, the opportunity to increase availability of equipment by shared spares pools and line replaceable units, farmer replaceable units, spares, common parts, all the usual stuff in systems engineering. And then we've got the governance side of how do we use the data to address some of our big challenges in terms of not polluting our rivers and making sure we don't spray too many bad chemicals on fruit as we grow it. So basically for our one, all we did is look at the industry, in this case kiwi fruit, look at all the different automation things we could do against different parts of their life cycle. And then we looked at trying to group where this line across the top is where we had common building blocks. So edge compute, cameras, LiDARs, weather stations, lighting on some of our equipment so the image recognition would work better, comms, radar, obstacle detection, navigation, sort of scale of robot, and down to the buzzwords and features within that normally make up a digital twin. And we started mapping these out around reuse to say, rather than different companies trying to do everything and not being able to do it, generally, what are the common parts? And as you can see on here, there's quite a lot of ticks in there. And especially this is a 2D view. If we layer that on for every, for strawberries and every type of fruit and vegetable, you'll find out there's actually quite a lot of commonality. Interestingly, looking at smart cities, we can do the same where a lot of the same equipment could be reused. And it doesn't have to be the same equipment. It can just be a case that you have an ecosystem of, it's not open source. It's more of a trusted source. So you could have people who are doing image recognition for rubbish trucks, which is a project we're working on at the moment to help with recycling. Why not use the same frameworks and people to do that as we're doing for image recognition in an orchard? The neural networks don't know the difference, and neither do we. We just label it and run it through. So that enables us to adopt more technology, and then we just came up with an architecture there around the the building blocks of the robot side of things and the building blocks of the industry digital twin. And we've got a video on that, but I can come back to that later if anyone's interested. But basically, in a lot of areas in New Zealand, we're not going to be able to adopt Industry 4.0 purely because it's too expensive and too hard to support, especially in the remote aspects, unless we start working together. And that could just be from sharing knowledge to sharing parts to sharing in a sort of gated source. So not open source, but gated source of non-competing trusted entities to get that reuse, increase utilization. So instead of a robot having to pay for itself in 3 months, we can use 3/4 of that robot, configure it within a day and getting it doing another function. So it halves the return on investment or drops it to a third by just reusing stuff. And then while we've got this equipment, we can start covering off some of the environmental stuff around tracking where you're spraying chemicals and what that might do to leaching in rivers and such. So that's the end of the talk that that we covered off. Just wanted we went into a lot more, but I just wanted to introduce that one. Which is, it's fine to do that, but I thought that it's key that I just jump through a few of the other papers that I thought were interesting and probably have a link back to New Zealand for some of you.
Is this the point to stop the recording, Nick?
Yes. Yeah, I think so. Yeah. Just
great.
Yep.
Out of an abundance of copyright caution, no problem.
Yeah. Well, just to be careful, I wasn't sure on the rules, so I'll just err on the side of caution.
All right. Here we go. Stopping the recording.
Brilliant.
Not